Here we're asked to find a couple of derivatives. For part A, we have h of x equals the quantity x cubed minus 6x squared plus 8x all over x squared minus 2x, and we're asked to find h prime of x, which is another way for writing the derivative. Okay, well, we still don't have a rule for division when it comes to derivatives, and even if we did, we will get that soon. It's called the quotient rule. You only want to use it kind of as a last resort because it's very cumbersome and tedious, though it would work. Instead, let's try simplifying, and then and only then, if there was something left to do, we would use that quotient rule. But first, let's just see what happens if we simplify this down, see if we can get out of having to use some kind of quotient in this situation. Okay, so let's just see. We can factor an x out of the top, so that leaves us with x squared minus 6x plus 8. That's looking a little better. And down below, let's get an x out of there. That leaves us with x minus 2. Okay, so there's the x is already gone. And now, so this is still h of x, by the way. We're not taking the derivative yet. Now we can factor this numerator. That's good news. I'm always down to factor some stuff. We just have x minus 2 hanging out down below. And it looks like this up here factors to, how about minus 4 and minus 2? That does the trick. And again, we get our cancellation. So now we're doing x minus 4 and taking the derivative of that. So let's do d by dx of that. Well, it's simply a polynomial. What's the derivative of x? What's the derivative of negative 4? Well, the derivative of x is simply 1, right? Because it's x to the 0, so we use the power rule. I'm sorry, this is x to the 1. We use the power rule. It becomes x to the 0, leaving this 1 just hanging out in the front. There's always an invisible 1 hanging out in the front there. The derivative of negative 4, since that's a constant, that's just 0. That's the constant rule. So after all that, we have h prime of x equals 1. And I'm just going to say a little more. Let's say that x does not equal 2 or 0 because the rules of differentiation only apply where the function is defined and it's not defined at those points. So let's keep that in as part of our answer as well. So even if we had the quotient rule, we wouldn't have wanted to use it in this situation. And I encourage you, if you'd like, if you actually really like spending a lot of time doing very tedious things, once we get the quotient rule, come back and do the same problem with the quotient rule. It's going to take much longer. So always best practice to cancel first before you try to take the derivative. Let's take a look at b. We have f of x equals the square root of x over 4 plus e squared, and we're asked to find f prime of x. Well, when you have any kind of radical and you're thinking about taking the derivative, you want to rewrite that. So here I'm going to rewrite it as f of x equals, how about 1/4 x to the 1/2, right? That's just using the rational exponent notation for a square root. So we have 1/4 x to the 1/2 plus e squared. Now we can take the derivative of this. Why don't you pause the video for 30 seconds or so and see if you can take this derivative. Okay. That gives us f prime of x. The power rule says we bring down the exponent and subtract 1. So this is 1/8. I'm bringing down and then multiplying. X to the 1/2 minus 1 is negative 1/2. Plus, okay, did you say 2e to the 1? E is a constant. It's not a variable. So this whole thing drops out when we take the derivative. The e squared just goes to 0. That leaves us with the final answer of 1/8 rad x. Why did I convert it to radical? Well, usually if they start us with a radical, it's just kind of polite to give the answer in a radical. That's kind of the rule of thumb I use on when to use radicals and when to use rational exponents for a final answer. Now again, imagine how challenging this would have been without the power rule, this part b, right? We would have had to use the conjugate and the limit definition of the derivative, which isn't the end of the world or anything, but it certainly is not as fast as simply bringing down the exponent and subtracting 1. So having the power rule certainly frees us up a little bit.